Hello, calculus fans. So we've got a new topic. We're going to be discussing series, infinite series. So to motivate this, let's think about what do we really mean when we say pi is equal to 3.1415926 and so on. That decimal goes on forever, and it has no pattern to it. In fact, you can prove that. So what we really mean is that pi is equal to 3 plus 1/10 plus 4 over 10 squared plus 1 over 10 cubed plus 5 over 10 to the fourth, and so on. And then I think we have to try to make some meaning out of what do we mean by adding infinitely many things. So the idea is that the more terms we add, the closer we get to the actual value of pi. So the general idea is that we're going to start with a sequence, and we're going to try to make sense out of the infinite sum, a1 plus a2 plus a3 and so on. And this is called an infinite series. And we're going to denote it with the sigma notation to write the sum, where n goes from 1 to infinity, of a sub n. Now, we can't actually add infinitely many things, but we can add finitely many things one at a time. And so what we're going to do is create partial sums. That is to say, we're going to start first by adding just the first term of the series. Then we have a1 plus a2. Then we have a1 plus a2 plus a3. And these things are called partial sums. So the nth partial sum is a1 plus a2 plus a3, so on, all the way up to an. So we'll use s for partial sum. We can use the notation where we say the sum, where k goes from 1 to n, of a sub k. So that big sigma just means sum. We're adding things up. So from our original sequence a sub n, we create a new sequence s sub n of partial sums. So that leads us to this definition, and this is essentially summarizing everything that we've talked about. So we start with a sequence a sub n, and then we create a new sequence of partial sums. This sequence of partial sums is what we mean by an infinite series. So if this new sequence, the sequence of partial sums, if it's convergent, and that we get a limit of s, which is a real number, then we're going to say that the series is convergent. And we're going to say that the sum is equal to s. If the sequence s sub n is divergent, then we say that the series is divergent. So essentially, when we're talking about a series, we mean a sequence of partial sums. Okay, that's all for now.